we are going to continue with the Wobble hypothesis. Actually, Wobble means the third base of the codon. Where is the codon present? On the messenger RNA. Which is the third base of the codon on the messenger RNA here? From the 5' end, we always count from the 5' end. G is the first base, C is the second base, C is the third base. So here GCC, this is the Wobble base. That means third base of the codon. The third base of the codon contributes to specificity, that's correct. But it pairs only loosely with the corresponding anticodon. Remember, this is the anticodon. Anticodon is a part of the tRNA. Codon anticodon pairing should be anti-parallel. So this is actually the 5' to 3' direction of the anticodon. So this is the first base of the anticodon, second base and third base. So the third base of the codon matches with the first base of the anticodon. Third base of the codon is the Wobble base. Okay. It pairs only loosely, permitting rapid dissociation of the tRNA from its codon during the protosynthesis. Why? Because the pairing and dissociation should be as fast as possible. Otherwise, synthesis will be a very slow process. You see, if all the three bases of the codon engage in strong Watson-Crick base pairing, then the tRNAs would dissociate too slowly, which means the rate of the protosynthesis will be very low. Speed will be very low. So there should be accuracy and there should be speed. Codon-anticodon interactions actually increase the accuracy. At the same time, speed is maintained because of the loose pairing between the Wobble base of the codon and with the corresponding anticodon. Remember, this is an extract from the Wobble hypothesis proposed by Francis Crick in 1966. Journal of Molecular Biology, 19th edition, page number 548, 555. The publisher is Elsevier. You can search this in the internet and you can see the original journal. You can see the original article written by Crick in 1966. You just type like this. This is the name of that article, codon-anticodon pairing, the Wobble hypothesis, Journal of Molecular Biology, 548, 555. If you type like that, you can see the actual journal. Okay. Actually, Crick's Wobble hypothesis has four postulates. Four concepts are there. Concept 1, the first two bases of the mRNA codon always form strong Watson-Crick base pairing with the corresponding bases of the tRNA anticodon and confers most of the specificity, accuracy of this tRNA, polypeptide chain synthesis. So, first two bases of the codon pairs with the last two bases of the anticodon with the maximum accuracy. This is ensuring accuracy of the polypeptide chain being synthesized. That is a postulate 1. Postulate 2, the first base of the anticodon reading in the 5' 3' direction, this pairs with the third base of the codon, determines the number of codons recognized by the tRNA. When the first base of the anticodon is C or A, base pairing is specific and only one codon is recognized by that tRNA. When the first base is U or G, binding is less specific and two different codons may be identified. Let us come to this postulate in detail. When the first base of the anticodon, starting from the 5' 3' direction, is C or A, base pairing is specific and only one codon is recognized. Let us see that in the genetic code. We are going to the previous slide. When the first base is C or A, only one codon is recognized. Let us see it. How do we know the first base, C or A? Here C is given here. Remember, these are actually the codons. We should go to the anticodon. So this is the anticodon here. First base is C. When the first base is C, codon is GGA. Anticodon is ECU. Codon is GGA. And how many T specifying this codon? This CCU is complementary to the codon GGA. GGA. It is specifying glycine. It is specifying glycine. Like that. To have a better comparison, we should have a table of anticodons nearby. And we should find out how many anticodons are actually specifying one amino acid. You can see an example here. CCU is specifying glycine, or a tRNA with anticodon CCU is carrying the amino acid glycine. How many tRNAs with the first anticodon C are carrying glycine? I think you understood. You should make a preparation. It will take some time. Do your work and find out how many tRNA molecules carrying first base cytosine in the anticodon are transporting glycine. Like that. Let us come to the previous one. How many tRNAs having the adenine as the first base of the anticodon are carrying any particular amino acid? Like that, you should do a work and find out whether this is really working or not. One thing is there, it is proven to be experimentally correct. And secondly, when the first base of the anticodon is uracil or guanine, binding is less specific and two different codons may be read. Two different codons for uracil, two different codons for guanine. So 2 plus 2 is equal to 4. Here in this chart you might have seen some of the amino acids have 4 codons. Some of them have 2 codons. Some of them have up to 6 codons. What may be the reason? Because of the wobbling. When the first base of the anticodon is either U or G, it will pair with the Wobble base, that means first base of the codon, and the binding is less specific and two different codons may be read. That's why some amino acids are being coded by more than one codons. Postulate 3. When an amino acid is specified by several different codons, the codons that differ in the first 2 bases require different tRNAs. The codons that differ in first 2 bases require different tRNAs. The same tRNA can carry same amino acid even if the anticodon is different, only if the third base of the codon is matching with the first base of the anticodon loosely. Okay. Postulate 4. A minimum of 32 tRNAs are required to translate 61 codons. 31 to encode the amino acids and 1 for initiation. What is initiation? Initiating amino RNA is actually methionine, AUG. So 32 tRNAs are there to specify 20 amino acids into 61 codons. You know that of the 64 codons, 3 do not specify any amino acids and they are stop codons. Clear? That means there are some amino acids being carried by more than one tRNA. because of wobbling.